All right, we got another differential equation problem, and in this one, we're actually just given the differential equation. Turns out to be a logistic model. So we have dp dt is 0.02p times 1 minus p over 2,000. Okay, so there we go. And it tells us initially the population of cells is 300. And so we're going to estimate the amount of cells after 3 hours. Okay, this is one of those poorly written textbook questions where they didn't actually define the variables, but that's okay. We're just going to assume that P and T are in whole number of cells and hours. Otherwise, I don't know how we do it. So I'm going to divide both sides by all of the P factors, because then they're going to go over on the left side, and I'm going to multiply both sides by the dt. So I have something that is a little bit annoying because I can't just do the natural log of each of those pieces because they're multiplied together, and there's no use substitution that works. There's no integration by parts that's going to work. Don't even worry about trying trig sub. You can do what's called a partial fractions decomposition. So you're taking your two-term or two-factor fraction, and you're writing it as the sum of two fractions, each with one of the original factors. And what you're solving for is what are the a and b values that make this true for all p values. So if you multiply through by the entire denominator here, it's going to cancel the p and the 1 minus p over 2,000, and it's going to give you an extra term right there. So what I'm doing is I'm multiplying both sides by p, so that cancels out this p and gives me a p on top of the b fraction, and I'm multiplying both sides by 1 minus p over 2,000. Cancels out this one under the b and gives me the extra term right there. Now, I want this to be true for every possible b value, or every possible p value, excuse me. So I'm going to plug in p equals 0. And if I plug in p equals 0, I get 1 equals a times 1 minus 0 over 2,000 plus b times 0. So that ends up being just that 1 is equal to a. Then I plug in p equals 2,000. Where did I get 2,000 from? Because that's going to get rid of the a factor. So if I plug in p equals 2,000, then I get 1 equals a times 1 minus 2,000 over 2,000. That's going to equal 0. Plus b times 2,000. So I get 1 over 2,000 equals b, because this was equal to 0, so I divide by 2,000. So now I'm going to go back to my differential equation, and I can rewrite it as the sum of 1 over p, because the a value was 1, and a was the part that I put over p, and then plus 1 over 2,000 times 1 minus p over 2,000 dp equals dt. The integral, oops, I forgot my point 2. I'll just put it over here, 0.02. Okay. The first part, 1 over p, just becomes natural log of the absolute value of p. The second part, those 1 over 2,000s are kind of annoying. So if you multiply the top by 2,000 and the bottom by 2,000, you just have 1 on top, and then you just have 2,000 minus p, which is great. So 2,000 minus p means that you've got a negative coefficient on the bottom, so you get a negative in front of your natural log. And then over here, we just have 0.02 t plus c. Wonderful. Okay, I'm going to combine my natural logs together. The natural logs are both positive because you have a positive number of cells, and initially the number of cells is 300, so we're in that positive branch of the domain. So we have p over 2000 minus p, 0.02t plus c. Then let's exponentiate both sides and drop down the c. So just a second. All right, I think what I was saying is you exponentiate, and then you get p over 2000 minus p equals ce to the 0.02t. I'm going to create a little space here. And what are we supposed to actually do? We know that there's 300 initially, and we're going to estimate the amount after 3 hours. Okay, so let's get the c value by plugging in 300 initially. So initially means t equals 0. So we can do 300 over 2000 minus 300, and that's going to equal ce to the 0.02 times 0. That equals 1. So we have c equals 300 over 1700, or just 3/17. And then we're going to estimate the population after 3 hours. I guess I need to solve it for p as well. So I'm going to need a little bit more space than just that little corner there. So let me create a little more space over here. So when you have a fraction like that, you're going to multiply by the denominator, then distribute it out, and then refactor it for the letter you're looking for, and divide. So if you haven't seen it before, it can feel like a lot, but what we have is this almost solved differential equation. I'm going to multiply both sides by 2000 minus p. So I get p equals 2000 minus p times 3/17 e to the 0.02t. Distribute that out and add this term to the left side. So now I have p plus p times 3/17 e to the 0.02t equals 2000 times e. I forgot my 3/17. I'll just put it at the end. Okay. Then if I factor out p from the left side, I have p times 1 plus 3/17 e. So then we get p equals, I'm going to divide. So I have 2000 times 3/17 e to the 0.02t over 1 plus 3/17 e to the 0.02t. So I've solved now for the population. So at any given time, I can plug in the t value, and that equation will tell me the population of the number of cells. Okay, so let's plug in 3, because the question asks about the number of cells after 3 hours. And this one right here is not going to be something that I can do in my head. So I'll just type it all in. And then we'll round it off to the nearest whole number, because I would be shocked if this came out to be a whole number of cells. But if you just type into your calculator exactly how I have it written there, then it will come out. Let's see. All right, so I got it typed in, enter, comes out to be 315 approximately. I guess if I rounded it up, it'd be 316 cells. So there you go. That's a logistic model. And when you're doing a logistic model, because you're usually going to have a p and then another p factor, you have to do that partial fractions decomposition, like we did, and then integrate both of those and combine those logs back together. And then the other thing with your logistic model is you'll do that trick where I multiply it by the denominator, distributed, recollected my p-values, and then factored, divided. So please let me know if you have questions. Thanks for watching.